In the first problem of this video, you're asked to write the ratio in this particular word problem in 3 different ways. So the word problem says the length of the pool is 22 meters, the width is 10 meters. What are the 3 ways you can write the ratio? Sure, not a problem. Can someone tell me what those 3 are before I give them to you? Well, the first way is you put the word 2 in between the 2 numbers. So in this case, in between 22 and 10, I'm going to write 2. So 22, 2, 10. That's an odd marker. The second way is you can put a column in between the 2 numbers. So I can say 22 to 10. And the third way I can do it is by putting them as a mathematical fraction. So put a division line between the 2 numbers. 22 over 10. So those are the 3 ways we can write this particular ratio. That's all the problem asks for us. Any questions? In that case, let's move on and let's take a look at number 2, which is on the right side. Number 2 asks us to simplify the ratios given to us. So what's the first thing I want to do before I even tackle that particular ratio, either one of those? Well, the first thing I would do is I would put them in their fractional ratio form, like this. These are both fine, but they're a little bit difficult to work with in math. We know how to deal with fractions, so let's put them both in the fractional form, and that's my favorite form. So that's the first thing I'm going to do. I'm going to put them both into their fractional form. Right here it would be 6 over 15. Right here it would be 50 over 24. Okay, what would I do next? Well, next I would try to simplify them. And to do that, I'm going to break down both numbers in the ratio or in the fraction into their base components. For the 6 over 15, I'm going to break the 6 down into 2 times 3. I'm going to break the 15 into 5 times 3. For the 50 over 24, I'm going to break the 50 down into, let's see here, 2 times 25. I'm going to break the 24 into 2 times 12. Questions so far? What would I do next? Next, I would cancel out what I have the same top and bottom in each of the fractions. So 3 gone, 3 gone, 2 gone, 2 gone. Alright, is there anything else I can cancel out right here? Nope, 2 over 5. That is the simplest form, essentially. There's nothing else I can do there. So I'm going to write it as 2 over 5. That is my simplest form. What about down here, 25 over 12? Is there anything I can do to simplify those ratios? There isn't. 25 I can write as 5 times 5, but 12 does not contain any 5s. Yes, I can write 12 as 2 times 6 or 3 times 4, but no 5s. So that is its simplest form. So we simplified both of those ratios. Questions on number 2? Number 3 asks us, and let me move it up a little quick here. Number 3 asks us to give me equivalent ratios, 4 of them, for this particular ratio. So we're trying to find 4 equivalent ratios. And I conveniently gave you a way to give me 2 that are larger and 2 that are smaller. Although technically You can give me 4 that are larger or 4 that are smaller, so any 4 will do. But I'm going to go with 2 on one side, 2 on the other side. So can someone tell me what should be this ratio right here? The first one to the right. If you said double both the numerator and the denominator, I would agree with you. You could triple it too technically. There's a lot of things you can do there. But doubling is definitely one way you can work this problem out with. So if I double both numerator and denominator, I'll get 24 over 48. And that works. It's an equivalent fraction. I just multiply top and bottom by 2. What if I asked you to go one more on this side? And again, you can triple it if you want, but I think doubling is perfectly fine. So if I double the top, I am going to get 48. And if I double the bottom, does anyone know what 48 times 2 is? It's 96. And that's also equivalent to this original ratio we started with. Alright, that's 2. Now let's do 2 that are smaller than our original ratio. 2 equivalents that are smaller. What's the next one over? Well, if you said just reduces the number by 2, so divide both top and bottom by 2, sure, that'll work, and that's the simplest way to go. So if I divide 12 by 2, it's 6. If I divide 24 by 2, it's 12. So that's an equivalent ratio. What about this one? 3 over 6? I agree with you. And that's that. Any questions on number 3? Let's take a look at number 4. Number 4 says, describe how to tell if 2 ratios are equivalent. You were supposed to give me a sentence here, not a long one per se. Does anyone have something they want to share? If I were writing this, this is what I would write. This is what I would put down. If I have 2 ratios and I'm trying to find out if they're equivalent, I would simplify both ratios to their simplest form. Then compare them. So you simplify them, and once they're in their simplest form, if they're the same, they're equivalent. If they're different in their simplest form, then they're not the same ratio. And you could have written something else down there, but it should be pretty close to what I have. Questions on 4? Let's take a look at number 5, right over here. You're being asked, are the 2 ratios equivalent or not? Well, what can I do to see if they're equivalent or not? Hey, look, I just told you. Simplify them, put them in their simplest forms, and then compare the simplest forms. And the way I simplify a ratio is I break down both top and bottom and see if I can cancel anything out. Can I cancel something out from this ratio, 6 over 9? Why, yes, I can. Because 6 is 2 times 3, and 9 is 3 times 3. I can cancel out a 3, which I'm going to do. 3 is gone. And I'm left with 2 over 3. Can I cancel anything there? No, it's the simplest form. Let's put the other one in simplest form as well. So 10 over 18. What can I cancel out of both 10 and 18? Well, I can write 10 as 2 times 5. I can write 18 as 2 times 9. I'm going to cancel out the 2 from both. Okay, that's done. Which leaves me with, 5/9. Is that the simplest form? Most certainly is. Are they the same fraction? Or are they the same ratio? No, they're not. So, not equivalent. Questions on number 5? Alright, moving on to 6. For number 6, you're asked to explain why the ratios 2 to 4 and 6 to 10 are not equivalent. And you could show some work here as well as I will, or you can just write a statement about it. But this is what I would say. I would say 2/4 simplifies down to 1/2. And 6/10 simplifies down to 3/5. Not the same. Very brief explanation. I could have definitely done more here, but I'm just showing you how basic of an explanation you can provide, and I'll accept it. So you could have definitely written more here. You could have written full sentences, but that's the minimum that I'll accept. Questions on number 6? Alright, number 7. We have a short word problem. It says Kenji earns $32 in 4 hours. How much does he make an hour? How can I find the unit rate here? What can I do? Well, the first thing I want to do is I want to write the ratio or the numbers in a ratio, or as a rate, because now we have relevant units. So it's going to be a ratio with units, which is a rate. So it's going to be $32 over 4 hours. What do I want to do next? What's my next step? Simplify, of course. What can I cancel out of both the 32 and the 4? I can cancel out a 4 because I can write 32 as 4 times 8. That's 4 times 8, not 4.8. And I don't have to do anything with the 4 because, well, it's a 4. I can write it as 1 times 4. I can write it as 2 times 2, but that's unnecessary because I can cancel these two out. So what am I left with? What am I left with? The $8 on the top and nothing on the bottom, so it's just the 1. So it's $8 over 1 hour, or $8 an hour. And that is the answer to that particular problem. Questions on number 7? Then let's take a look at number 8. Can someone read this problem out for me? Alright, so we have 2 stores selling ribbons and we're trying to figure out which one is cheaper. What would I do? What's my first step? Well, I need to find the unit rate of the ribbon at each store, and that'll tell me which one is the cheaper of the two. So I'm going to create ratios out of the two store values, but don't forget that the money, the dollar, has to go on the top of the ratio to make this work. I told you this in the video lesson. So the first ratio is going to be $10 over 12 yards. I'm just going to write Y for yards. Okay, now what should I do next? Unfortunately, these are not going to be able to cancel out evenly. So what I'm going to do is I'm going to use long division to get me an answer where I only have one number that I'm dealing with. This is what I mean. So how many times does 12 go into 10? It doesn't. So I write a 0. How many times does 12 go into 100? 8. That gives me 96. And the remainder there is 4, but I'm not going to worry about that so much. That's good enough for me. 0.8 is going to be good enough for me. So for the first store, my unit rate is $0.8 per yard. That's my first unit rate. Now let's find the other one. So let's put the value mart ratios. Again, the money's going to go on top, and the yards are going to go on the bottom. Here, do I need to do a long division? No, because it simplifies down. I mean, I can cancel 5 with a 5. Yay, for easy problems. Which leaves me with just the 1 on the top, so this is just $1 per yard. Alright, now that we have the two unit rates, which one's the better deal? This one right here. So the major brand retail store in this case has the cheaper price. The Value Mart, even though it's a Value Mart, it's not cheaper. Mostly probably because you're buying more from the retail store and it's a shorter ribbon from the Value Mart. But anyways, questions on number 8? In that case, let's move on and do our last problem. Number 9. Can someone read the problem out for me? Nine is very similar to number 8. So what would I do first? I would find the unit rates. In this case, how many cars does Edward wash? Or how much time does it take for Edward to wash a car? Alright, not a problem. So this is how I'm going to set up the problem. Since Edward can do 6 cars in 54 minutes, so it takes him 54 minutes. I'm going to write just min for minutes over 6 cars. Now you might ask me, why did I put the minutes on the top and cars on the bottom? Well, think about it this way. If I put the cars on the top and the minutes on the bottom, that would mean I would have less than a whole number. But I know he definitely can do a car in several minutes, so it logically wouldn't make sense. So minutes go on top, cars go on the bottom, because if it was the other way around, the answer would not make any logical sense. Now, you might ask me, why did I put the minutes on the top and the cars on the bottom? Technically, it's a ratio. It doesn't really make a difference, but I want to see how long it takes for him to wash a car. If I flip the fraction, instead I would get how many cars Edward can wash in a minute. Well, that's useful too, but it's a bit weird. You would get a decimal number, and again, it would be how many cars Edward can wash in a minute. It would be like a 0.1 or 0.2 cars. It's just silly. So this way, I will get how many minutes it takes for one whole car. That's why I'm setting the problem up this way, with the minutes on top and the cars on the bottom. You could do it the other way too. It'll technically work. But this just, I don't know, makes it easier for me. What do I do next? I would simplify by first breaking down the 54, and I don't really have to go very far because 54 contains a 6. 54 is 6 times what? It's 6 times 9. So I can write 54 as 6 times 9. I'm going to keep the 6 cars on the bottom because I don't need to simplify the 6. It's going to get canceled out. What am I left with? 9 minutes per car. And that's Edward's rate. That's Edward's rate. Now let's look at John's rate. And I'm going to work out John's rate down here. So for John, he washes 8 cars in 62 minutes. So this is the ratio I'm going to come up with him. Again, I'm putting the minutes on the top. You could have done it the other way around, but you would be dealing with decimals. You would be figuring out who can wash more of a car in a minute. Again, it's a kind of a silly concept. They would both wash less than a car in a minute. You're just trying to figure, we would have been figuring out who can do more of this car in a minute. I think this is better. What do I do next? Well, unfortunately, 8 does not go into 62 evenly. So what we need to do is use long division. So we are going to use long division here. How many times does 8 go into 62? 7 times, and that's 56, which leaves me with a remainder of, let's see here, 6. Yeah, and 8 does not go into 6, so I would add a decimal there. That's 60, 7 again, and that's good enough for me. I don't need to go any further than that. So 7.7 minutes per car for John. So if quality was not an issue, who would you want working for you? Who would get more cars done? John would, because he only needs 7.7 minutes for a car, while Edward needs 9 minutes. Now, obviously, John could do a poorer job, but if we're just going with speed, John is the speedier of the two. Questions on number 9? Thank you.